Good day scholars, welcome to today's class, and in today's class we'll be taking past questions on STC 112, which is the course code for Inorganic Chemistry 1. Alright, let's start. The first question here says, define the concept, empirical and molecular formula, and give the relationship between the two. Now let's start. When you are talking about empirical formula, it is the simplest formula of the molecule of a compound. Now, let me give you an example. If you have C6H6, this is a molecular formula, and the molecular formula is the actual formula of a compound. Now, to get the empirical formula, the simplest formula of a molecule in a compound, so you have CH. This is the simplest. You cannot divide it more than this. You cannot divide it further. Now, another example, C2H4 is a molecular formula, which is the what? Actual formula of the molecule of a compound. Now, the empirical formula will be what? CH2, because you can actually divide this by 2, which is 1 here, 2. So that's going to give you 2. Then is what? The empirical formula of this compound. Now, the relationship between these two, the molecular formula and the empirical formula, is that when you are talking about the molecular formula is a multiple of the what? Empirical formula. So you can as well say, if this is the what? C6H6, you can write it as what? CH into brackets base 6. So you, in this one, you are saying that this is actually the empirical formula, but it is the same as the molecular formula. So this relationship shows that the molecular formula is a multiple of the empirical formula. So that's that about that. Now to the second question, it says, this is a calculation question. It says one of the active ingredients in vinegar is ethanoic acid. Now the molecular formula for ethanoic acid, CH3COOH. Ethanoic acid has a molecular mass of 60 grams per mole. Take note, the molecular formula 60 grams per mole. And the following percentage composition, which is carbon, hydrogen, and oxygen, we are given. Actually, the composition of ethanoic acid contains carbon, hydrogen, and what? And oxygen. So we are given a percentage of each component of atom. For carbon, we have 39.9%. For hydrogen, we have 6.7%. And for oxygen, we have 53.4%. So the first question says, determine the empirical formula of ethanoic acid. Now, to determine the empirical formula, you can as well use a table for simplicity. Now, we have been given the percentage composition of each of these atoms in the compound that we are given, which is ethanoic acid. Now, we were not given the what? The molar mass of each carbon, of each atom. Now, let's check. For carbon, the molar mass of carbon is what? 12. The molar mass of hydrogen is 1. And the molar mass of oxygen is 16. These are constants that you should know. You will not be given as a first year student of any institution. You should know them right from secondary school. So now, you have to divide by each molar mole of each atom. Now you have to divide the percentage of each atom. We have divided by 12 for carbon. This you have to divide by 1. This you have to divide by 16. So now we've divided by each mole. Now we need to divide. The next step is to divide by the smallest. Now here, if we check, we'll see that the smallest value here is 3.33. Likewise from these two, 3.33. So you need to divide everything by the smallest. So we have divided by 3.33, divided by 3.33, then also here divided by 3.33. So here 3.33 divided, here you have 1, here you have approximately 2, and here you have 1. So without further ado, our empirical formula will now be, here we have C is 1, so you have 1, C. Now your H is 2, so you put H2, and your O is 1. So, and this is our final answer, and this is our what? Empirical formula. Take note, the empirical formula. You divide by the mole that you have, which are constant, and then the next step is that you divide by the smallest. And after dividing by the smallest, you get your whole number ratio and you input it into the what? Atoms, and that gives you the empirical formula. Now to the next question here, we have determine the molecular formula of ethanoic acid. Now, to get the molecular formula of our ethanoic acid, what we do is that, take note that I've told you earlier that the molecular formula is a multiple of the empirical formula. So we need to apply that now. So we have our empirical formula, which is CH2O, and is a multiple of something. So this is our multiple, N base, and then equal to, now we have been given the molar mass, which is what? 60 gram per mole. So you equate it to 60 gram per mole. 60 gram per mole. Now we are getting closer to the answer. Now, following the moles of each atom here, we have C, which is what? 12. You add it up, plus our hydrogen is 1, which is 1 times 2, plus oxygen that is 16. We have 16. Base N equals to what? 60 gram per mole. Don't forget, this is our molecular formula altogether with this base N. But this here is the empirical formula. So we need to get the value for this N and multiply it with this to get our molecular formula. And that's what we want to do now. So we add it up, which is 12 plus 2 plus 16, all base N equals to 60. And then we have 14 and then 30. So we have 30 base N equals to 60. So to get our N, we divide both sides by the coefficient of N. So our N equals 2. So since our N equals 2, then we go back to this and we input our N to get our molecular formula, which is a multiple of the empirical formula. So we have CH2O. Our N here is 2. We input it. So that's going to give us C2H4 and then O2. So this is our molecular formula. C2H4O2, the actual formula of ethanoic acid. And if you check, this is ethanoic acid normally, but this is the molecular formula. Let's check it out. We have 2 carbon here, so as 2 carbon here. First carbon, second carbon. We have 4 hydrogen. This is 3 hydrogen. This is plus 1, making 4. And then 2 oxygen here. We have 1, 2. So that's 2 oxygen. So this shows that this is correct as the molecular formula, and this is our what? Empirical formula. Molecular formula is a multiple, 2 times multiple of what? Empirical formula for ethanoic acid based on the question. Now let's move to the next question, which says the compound sodium hydrogen carbonate. This is a new question. Sodium hydrogen carbonate is commonly known as baking soda. A recipe requires 1.6 gram of baking soda mixed with other ingredients to bake a cake. The first question says calculate the number of moles of sodium hydrogen used to bake the cake. So now we are given sodium hydrogen carbonate, which is our what? Baking soda, CO3. Baking soda, and it requires what? 1.6 gram of baking soda to bake a cake. So we're asked to calculate the number of moles of sodium hydrogen carbonate, which is the baking soda used to bake a cake. Now we have been given the mass. To calculate the number of moles, the formula is moles equals what? Mass, the actual mass, which is what we have been given here, over molar mass. Don't forget, as I said earlier, to calculate your molar mass, you must have known the constant, the mole, of the number of mole of each atom of an element in the compound you are given. So let's check this out. Na is what? 23 hydrogen is 1, carbon is 12, and oxygen is what? 16. That aside, carbon is 12, oxygen is 16. But don't forget that we are given 3 atoms of oxygen, so we need to multiply by 3. So now we have the mass, we need the molar mass, so we need to add this up. 23 plus 1, that will give you 24. 24 plus 12, that will give you 36. And then we have our 16 times 3, which is what? 48. 48. So 48 plus 36, that will give us 84. 84. So now to get the number of moles, we have been given the mass 1.6 grams. So that will be what? 1.6 gram all over 84 gram per mole. 84 gram per mole. So that's our molar mass. So to get the number of moles, we have moles equals 1.6 gram divided by 84. So that's going to give us 0.019 moles. So that is the number of moles of baking soda that is required to bake a cake according to the question. The second question says, how many atoms of oxygen are there in 1.6 gram of baking soda? So now, to get the atoms, we need to get number of atoms. The formula we are using is number of atoms will be equal to what? Our moles times Avogadro's number. And Avogadro's number is what? 6.02 times 10 raised to the power what? 23. So the number of atoms of oxygen that we have there will be the number of moles of 0.019 moles of sodium baking soda that we have times Avogadro's number. But before we do that, we need to get the number of moles of oxygen in this baking soda to then multiply it by what? By our Avogadro's number. The number of atoms of oxygen in this baking soda is 48, and the overall molar mass of this is what? 84. So we need to multiply it by 0.019 moles to get the number of moles of our oxygen. So that will be 48 divided by 84 times 0.019. So that's going to give us 0.0108. 0.0108. So that's the number of moles of oxygen that we have in this place. So to get the number of atoms of oxygen, we need to multiply it by the constant, which is Avogadro's number. So we have number of atoms of oxygen will be equal to this 0.0108 times Avogadro's number times 10 raised to the power 23. So we have 0.0108 times 6.02 times 10 raised to the power 23. So that will give us 6.54 times 10 raised to the power 21. 6.54 times 10 raised to the power 21 is the what? Number of atoms of oxygen in 1.6 gram of baking soda. So the second question says, in an investigation, 256 gram of SO2, 256 gram of SO2 reacts with 80 gram of O2, 80 gram of oxygen, 80 gram of oxygen in a reaction vessel. The contact process is given by the equation below. Actually, this is one of the process. Contact process is one of the process used to what? Produce tetraoxosulfate 6 in the industry. But this is the third process that we're about to write out. This is SO2 plus O2 to give you what? SO3. They are all in the gaseous state. The gaseous state. Now, the first question says, balance the chemical equation. Now, to balance the chemical equation, we check for each atom, the number of atoms. Here we have sulfur, 1 sulfur, 1 sulfur, 2 oxygen plus 2 here, making 4. Here we have 3 oxygen. So we need to balance up. So how do we start? We start with our oxygen. It is 4 here, it is 3 here, so we need to do something. So let's check out 2 here. We have 2 sulfur here. We need to have 2 sulfur here. So 2 sulfur, 4 oxygen plus 2, 6. Then 2 times 3 is 6. So it is balanced. It is balanced now. 2 sulfur, 6 oxygen, 6 oxygen. So that's that. So now the next question says, calculate the number of moles of each reactant present at the start of the reaction. Now, I said it earlier that when you want to calculate the number of moles, you have to use what? Mass over molar mass. Mass over molar mass. And that's why I said, as a first year student of an institution, of any institution, you must know the value for each atom. So now, we have been given the mass. This is our reactant, SO2 and O2. So we have to check out the molar mass. So now, for SO2, we have sulfur is 32, oxygen is 16. So now the mass, I've been given 256. So that will be 256 gram divided by our molar mass is SO2. So that will be 32 plus 16 times 2. So that will give you what? 64. So that's 64. So now we have to do 256 divided by 64. So the number of moles for the first reactant is what? 4 moles. For the second reactant, we have mass over molar mass. So our mass is what? 80 gram. Mass over molar mass. So that's giving us 80 gram over O2, which is what? 32. 16 times 2. So that will give you 80 divided by 32, and that will give you 2.5 moles. 2.5 moles. So that's the answer. The number of moles of each reactant. The first reactant is SO2, the second reactant is O2. So mole equals to mass over molar mass, and then the moles for the first reactant, SO2, is 4 moles, and for the second reactant, we have 2.5 moles, according to the values that were given in the question. Now, let's move on. The question says, identify the limiting reagent in the reactant and justify your answer. So, in this reaction, there's a limiting reagent, but when you're talking about a limiting reagent, it deals with the what? With the reactant. It means as you are adding SO2 and you are adding O2, there is a particular reagent out of these two that will be what? That will be in excess, and one of them will be limiting. That means there is one that will first finish before the other finishes. So the one that first finish will be the what? The limiting reagent. And we are asked to justify our answer. So how are we going to do that? According to the values that we have here, if 2 moles of SO2, 2 moles of sulfur 4 oxide, is going to require 1 mole of SO2, sorry, 1 mole of oxygen, O2. So according to the question we are given, it says 4 moles of SO2 reacted with 2.5 moles of O2. So according to the standard equation, which means if 4 moles of SO2, if we have 4 moles of SO2, that means it is going to require 2 moles of what? Of O2 to react. So this is 4 moles of SO2 required 2 moles of O2. According to the standard equation, 2 mole SO2 require 1 mole of O2. So if you are having a particular mole of SO2, it is going to require the half of the oxygen to react. So now we have 4 moles of SO2 to react with 2 moles of O2. So by the time we expend all our 4 moles of SO2 here, we are going to have what? 0.5 mole of O2 left. 0.5 moles of O2. So therefore, we can say that our oxygen is the what? Excess reagent. Excess reagent. While the SO2 in this question is the what? Limiting reagent. Because once the SO2 is expended, the reaction is going to stop. Meanwhile, we still have enough O2, which is what? 0.5. So according to the question, which says identify the limiting reagent in the reactant and justify your answer. This is the justification of the answer, and what? Our SO2 is the what? Limiting reagent. Because 4 moles of SO2 will require 2 moles of O2. And according to the question we were given, 4 moles of SO2 reacted with 2.5 moles of O2. So we have 0.5 moles of O2, which is oxygen, left. So O2 is the excess and SO2 is the limiting reagent. So now that's that about that. Question 2a says define the following. First one, molality. The second, molarity, and the third, normality. Molality is the number of moles of solute per liter of solution. Your solute can be your salt, your table salt, which is what? Sodium chloride. But when you are talking about solution, it is the mixture of your solute and your solvent. So to get your solution, you have, for example, if you have 2 grams of solvent and you have 2 grams of your salt, making 4 liter of solution, then if you have 2 moles of your solute, which is sodium chloride, so the number of that solute per the liter of solution that you have is the what? Molality. And when you are talking about molarity, molarity is the number of moles of solute per the kilogram of solution. You know they are very close, but take note, for molarity, it is the number of moles of solute per kilogram of solution, while for molality, it is the what? Number of moles of solute per liter of solution. So now, to get the 2b, is a calculations question. It says a 4-gram sugar cube, which is sucrose, is dissolved in a 350 ml till cup of 80 degrees Celsius water. Now, what will be the molality of the sugar solution? So now, we are dealing with molality here. Don't forget, number of moles of solutes over the liter of your what? Solution. Of your solution. So now, 4-gram sugar cube, sucrose, we have sucrose, which is your solute. Solute is what? 4 grams. 350 milliliter teacup of 80 degrees Celsius. So our liter of solution, which is solution, is what? 350 ml. 350 ml. So we are asked to what? Calculate the molality. So now we are given the gram of the solute, but don't forget that we need the moles. So our mole is what? Mass over molar mass. Don't forget, mass over molar mass. And then our solution, our solute is what? C12H22O11. C12H22O11. So now to get the moles of this solute, which is what? Our sucrose, we need to get mass over molar mass, which is, our mass is 4 grams all over. So now I said molar mass again. So carbon is what? 12. Don't forget, carbon is 12, hydrogen is 1, and oxygen is 16. So we have 12 times 12 for carbon, plus our hydrogen will be 1 times 22, plus our oxygen, which is 16 times 11. So then we have it to be 4 grams all over 144 plus 22 plus 16 times 11. So let's add up and divide, and we have our molality, our number of moles rather. So that will be 144 plus 22 plus 16 times 11 equals 4 divided by answer. So our number of moles, don't forget that we are still getting our number of moles to be what? 0.012. 0.012 moles of what? or sucrose. So now for this, we already have the number of moles. Now we need the liter of solution, but don't forget that we are given, for the solution we are given in milliliter, so we need to convert to liter. So to convert 350 milliliter to liter, you have what? 0.35 liter. So now to calculate our molality, we have 0.012 divided by 0.35 liter moles. So moles per liter. So our answer there will be divided by 0.35. So that will give us 0.0334 but moles per liter. But it is very, very important to always leave our number in a standard form, so we can have 3.34 times 10 raised to the power minus 2 moles per liter of what? Of solution. So that is the what? Molality according to the question number 2, molality. So now the next question says, write the word equations below as chemical equations and balance it. So the first question says zinc and lead nitrate react to form zinc nitrate and lead. So we have to, it is written in words and we need to write it out. Zinc, the symbol is Zn, plus lead nitrate, lead 2 nitrate, PbNO32. That reacts to give us zinc nitrate, Zn, NO32, plus what? Lead. So we need to balance it up. So we have, let's start. This is zinc, 1 mole of zinc. For lead, we have 1 mole of lead, 1 mole of lead. We have 2 moles of nitrogen, 2 moles of nitrogen, 6 moles of oxygen, 6 moles of oxygen. So it is balanced up. It is balanced up. No problem with that. So the second one says that aluminum bromide and chlorine gas. So your AlBr3 plus chlorine gas, Cl2, react to give you aluminum chloride, AlCl3, plus your bromine gas. So now, to balance it up, we have 1 mole of aluminum, 1 mole of aluminum, 3 moles of bromine, 2 moles of bromine, 3 chlorine, and 2 chlorine. So now, to balance it up, we start from chlorine. Chlorine is 2 here, and chlorine is 3 here. So we bring 3 here, and we bring 2 here. Collect like time. So we add up 2 here, we bring what? 3 here. That's how to start balancing. So we have 6 chlorine and 6 chlorine here. 2 times 3 is 6. So chlorine is balanced. So we need to balance up the what? Aluminum. So we put 2 here. So we have 2 aluminum, 2 aluminum. So aluminum chloride is balanced as a whole. So we have 6 bromine here and we have 2 bromine here. So we add 3. So making 6 and 6. So everything is balanced. It's chemically what? Balanced. The third question says sodium phosphate and calcium chloride. We have Na3PO4 plus calcium chloride CaCl2 to give calcium phosphate, that's Ca3PO42, calcium phosphate. Then that will give us plus what? Sodium chloride. So let's see, we have 3 sodium, 1 sodium, 3 calcium, 1 calcium, 1 PO4, and then 2 PO4. So how do we start this? So we have 3 calcium. Let's balance up the calcium. We have 3 calcium here, 3 calcium here. So that's balanced. We have 6 chlorine. So let's have it. We have 6 chlorine. Chlorine is balanced. So we have 6 sodium. We have 3 sodium here, so we need to add 2. That's 6 sodium. So what else? We have PO4. So that's 2 PO4. 2 PO4. Then we have 2 PO4. So it is chemically balanced. Let's check. 6 sodium, 6 sodium. 2 phosphate, 2 moles of phosphate. 3 moles of calcium, 3 moles of calcium. 6 moles of chlorine, and 6 moles of chlorine. So that's that for that. Now this is section C on STC 112. Remember, we are solving past question 2017-2018 session. Now the first question says, where can the following halogens be found? The first one, fluoride ions. Fluoride ions, most especially, can be found in your toothpaste. So when you use your toothpaste to wash your mouth, they are the particular ions that helps in the whitening of your teeth. So the second question says chloride ions. Chloride ions can be found in table salt and seawater. The third one, both bromide and iodide ions. These ones can be found in minerals and also in salt water, but they are minimal, unlike the chloride ions that are the major ions in seawater. Then the 5b says, briefly explain the reaction of chlorine with water. So let's take note, the reaction of chlorine with water. So we have our chlorine gas plus what? Water. Let's take, for example, if this is rainwater, so chlorine reacts with this water, so what? Give you HCl plus what? HOCl. This is hydrochloric acid and this is hypochlorous acid. So we are asked to explain briefly the reaction. So let's say this is rainwater. So the thing is that this is hydrochloric acid, so it's acidic, and this is hypochlorous acid. This is acidic too. But the thing is that this is the one that affects the dye in our clothes. So when there is rain and rain falls and you use it to wash a cloth that has already been dyed, it is going to affect the dye in that clothes, and that's why you always say that the clothes has washed away. You buy a dyed cloth and it has washed away. It is because of what? This hypochlorous acid. It is the one responsible. So that's why sometimes if you use rainwater in particular to wash your clothes, it is what? It is going to make the color fade away. It is the work of this hypochlorous acid. So the next one says, name the following oxoacids of halogens. Ci, the oxoacid of halogens. We have HOClO2. This one is chlorous acid. We have chlorous acid. The second one says HOClO3. We have chloric acid. Third one says HOBrO3, which is our bromic acid. And the last one says HOF, which is our hypofluorous acid. So the next question says, calculate the oxidation state of the following compounds. So for the first compound here, we have Mn2O3. So Mn2, first one says Mn2O3. So we are asked to calculate the oxidation state of the O compound. Now to calculate the oxidation state of this O compound, the oxidation state of this compound is what? It is 0. Why? Because it is not a charged compound. It is not charged. So everything here is equated what? To be 0. So now the next one says MnO4 2 minus. We have MnO4 2 minus. Now the oxidation state of this O compound is what? Is what? -2. Is a O compound. So the oxidation state is -2 because the O compound has already what? Added oxidation number, 2 oxidation number, 2 electrons. So the oxidation number is what? -2. So now for the third, we have MnO4 minus. MnO4 minus. So the oxidation number of this compound is what? -1 because it's carrying minus here. So now you understand the trend. This one is 0. The oxidation number for this is -2. This is -1. The last one here the oxidation number is Fe3 plus. Yeah, Fe3 plus. So that will give us the oxidation number here is what? Plus 3. Plus 3. So that's that for that. The next question here says list 4 chemical properties of fluorine. One of the major chemical properties of fluorine is that it is highly reactive, very, very reactive, and it has the ability to react with all elements except from the noble gases. And the reason it cannot react with noble gases is because noble gases already have a full electronic configuration, so there is no space for them to react with any element again. That's why it cannot react. So it is very, very highly reactive. So the last question here says that state 2 uses of bromine. One of the major uses of bromine is that it is used as a flame retardant. That is, it is used to what? Put out flames. And the second use is that it is used in photography. That is in silver bromide. Silver bromide in particular, it is used what? In photography.